Okay, so it's quite important, especially as you can see in a pandemic, it's quite difficult sometimes to make the connection. So we have to make use of every opportunity which we have to learn. Now, you know, you guys have done the atom since grade 8, grade 9, grade 10, and now you're in grade 11, and every year you do chemical equations. Am I right? Am I right? I was wrong around about in the 1960s. I was wrong once, but I think I'm right to say that you've been doing chemical equations since grade 8. You've been reacting things together. Okay. So, you know, here's the strange thing. People get to matric and they still haven't got a clue of how equations work. What is it? It must be the teachers. I can only blame the teachers. Cannot be the student. It's the same with you've been doing electricity since grade 8, grade 9, grade 10, grade 11. And yesterday I was tutoring a person in grade 12 on electricity. And what do they know? The square root of nothing on electricity. Okay, but we're going to cure that. So what I'm trying to say is get into the attitude of everything we say today, you must master and know. How about that? Okay, now I see you've also got your notebooks there, so take a few little bits of notes. And I'm just going to go and share with you, just quickly, I want to revise what we learned last time. Okay, so we learned moles, right? Do any of you remember what we did to represent moles last time? Come on, silly science. Thank you, that person on the back left. Yeah, we did that. Won't everyone do the sign for moles? Okay, that's moles. There, that's like a little mole under the ground. Okay, number of moles is mass over molar mass. Okay, here's the symbol for mass. Won't you do that? That's the symbol for mass over molar mass. So molar mass. You've got to do two things for molar mass. Okay? So what is the number of moles? It's the mass over the molar mass. So if I said to you, I've got 6 grams of carbon and the molar mass of carbon is 12, which you'll find on the periodic table, then you've got 6 upon 12, or half a mole of carbon atoms. Okay. Then a second formula was concentration is number of moles over volume. Now, here's my symbol for concentration. We're taking something and we're squeezing it together. Won't you do that? That's the symbol for concentration. Squeezing it together. Okay, so concentration equals moles, M stands for moles, divided by volume. Okay, there's your symbol for volume, or decimeter cubed. Okay, so concentration equals moles divided by volume. Okay, so there's your two things, and then here, 22,4 decimeters cubed. So there's 2 decimeters in a milk bottle. If you take 11 of those, you've got 22 decimeters cubed. You've got a mole of gas. Okay, so if you had to count the number of particles in 22 of these bad boys, you're going to get 6,02 times 10 to the 23 particles of gas. Now we call this special number Avogadro's number. So in a mole of air molecules, which is 11 of these guys, you're gonna, if you start counting and you count for 1,000 years, you're gonna end up with this number, 6 with 23 noughts, and that's called Avogadro's number. Okay, I'm going to share with you, there are some lovely sites online on balancing equations. Let's just find one of them. Okay, here's a site. Okay, so let's just share with you this site. Share screen. Okay, can you all, I take it you can all see that. So this site is called, I can't quite see what it's called. It's called fetcolorado.edu. Okay, it stands for Physics Education Technology of the Colorado University Education Department, or EDU. Okay, do you recognize, here's an equation. Here we got nitrogen gas plus hydrogen gas goes to form ammonia. And we're doing a topic called stoichiometry. We've got to find the ratios in which these three sort of react. And they've got this lovely thing here. You can add molecules to that or not. And then they've got a little thing here. We've got a scale. Okay, so if you add molecules of nitrogen, the scale means you've got 2 on the left, but you've got none on the right. And this is a way that you can teach yourself to balance equations. And you've got to be able to balance equations before you can do stoichiometry. So when your parents ask you, what have you done today? What have you learned today? You can say stoichiometry. Okay, so we can add numbers in front only here. Now, do you know that that is a molecule of nitrogen, that is a molecule of hydrogen, and that is a molecule of ammonia? Would you guys have known that nitrogen only comes in pairs of 2? Would you have known that? Hands up. Anyone know that? Nitrogen comes in pairs. So nitrogen's got a valency of 3, nitrogen's got a valency of 3, and they always float around in the air. 80% of the air of what you're breathing in is these nitrogen molecules, then they're linked up in 2s. Have you guys known, obviously you know that hydrogen comes in pairs. Come on, you did it in grade 8, grade 9, grade 10, grade 11. Hydrogen doesn't float around like this. It always links to another hydrogen and comes as H2 gas. But I don't think you would have known that NH3 has that formula, but maybe you should have, because here's 1 nitrogen, and here's 1 hydrogen, and there's 1 hydrogen. We need another hydrogen, and we need a 3rd hydrogen to fill all the covalent bonds. So you could have worked out that because nitrogen's in group 5 and hydrogen's in group 1, that you needed 3 hydrogens for every nitrogen. Guys, don't fall asleep. You've got to be able to work these things out. You must be able to, for simple things like this, be able to say, if something's in group 1 combines with something in group 5, it always combines in the ratio 3:1. That's stoichiometry. Okay, so suppose you know the formula for hydrogen gas, nitrogen gas, and ammonia. And this, by the way, is a very important process. It's called the Haber process. You carry it to matric. You've got to know this, guys. So let's try and balance it. Okay, it's a bit busy here, but let's see what happens. So we got what you can't have less than 1 of anything. So let's raise everything to a 1. And just see if it's balanced. Because if it's 0, it means we don't have nitrogen. 0 here would be we don't have, but we do have, we start. I don't know why they don't start us with 1. Okay, do those look balanced? Yes or no? Put up a thumb if it looks balanced. Put a thumb down if it doesn't look balanced. Okay, that's not balanced. Look, those are not balanced. You got 2 nitrogens on the left, but you've only got 1 on the right. 2 nitrogens, 1. So that's obviously not balanced. So what are we going to do? We're going to have to raise the number there to a 2. Now look at that. Look at that. The nitrogens are balanced. So we can put a big tick there and a tick there. We balance the nitrogens. But now look at the hydrogens. The hydrogens have got too few on the left. Because we've got how many hydrogens? 2 times 3 is 6 hydrogens on the right. 1, 2, 3, 4, 5, 6, and we only got 2. So what are we allowed to do? Can we change that number? No, because that's the ratio in which they always combine. So we can only increase this number. Bingo! Isn't that cute? So now we know that 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. Okay, now guys, what I want you to do is I want you to work out how many grams of nitrogen react with how many grams of hydrogen to form how many grams of ammonia. And if you haven't got a periodic table, I guess I could just read it off for you. It's so simple. Nitrogen is got an atomic mass of 14, and hydrogen's got an atomic mass of 1. So come, this is almost mental arithmetic. What's 2 14s? That's 28 grams of that is going to react with 3 times 2 is 6 grams of that. So that 28 plus 6 goes to form 28 to 9, 34 grams of ammonia. Could we maybe write that down? Okay, I'm just going to go to my blackboard here. Okay, so I'm going to stop share. So what was the formula we had? N, I forget, plus H goes to form NH3. Was it H on the left? I can't remember. But anyway, we found that we had, this always occurs as 2. So we always have to start by making that a 2. But now we look, we've got 2 there, we've got 1 there, so we make that a 2. So now we can say, yes, we've got our correct amounts of nitrogen. Let's look at hydrogen. 2 times 3 is 6, only 2, so we've got to put a 3 there. Okay, that's step 1. Now step 2, let's find how much 2 nitrogens weigh. So it's going to be 14 times 2 plus 3 times 2 is 6 times 1 goes to form 2 times 14 plus 3. Okay, there's 2 lots of 14 for nitrogen, 3 for hydrogen. So that's 2 times 14, 15, 16, 17, 34. And this is 14 times 2 is 28. And that 6 times 1 is 6. And those numbers must add up. Otherwise, we've made a mistake. Okay, so we've got 28 plus 6 is 34. Now, that is the ratio in which nitrogen combines with hydrogen to form ammonia. Cute, nice, everything? Happy? But what if I said to you, instead of having 28, if I say, start with, let's suppose I say, yeah, but unfortunately, I've only got 10 grams of that. My question to you is, if I've got 10 grams of that, how many grams of that would I have to add to it? And I remember I was teaching this at, just before the matric exams, we go and we revise the whole year's work. And I was at some school, Rocklands, I think it was, teaching this. And I was saying, well, look, if you've only got 10 of that, what you do is you take the 10, you put it upon the 28, and you multiply it by that one, which is 6. And then you're going to, let's just get a calculator and we do that. So we say 10 divided by 28 times 6 gives us 2.14 grams of hydrogen gas would be needed to react with, if we only have 10 grams of nitrogen gas. And then some girl said to us, okay, in our school, I want to show you how our teacher does it. And I thought, what? Okay, fine. They looked a little bit confused. So let's just remember the answer was 2.14. So if, this is how she said they did it. Let's suppose you've got, let's suppose you've got 5 grams of this substance. You don't have, so you work out your molar masses. And I ask, how much of that do you need? Would you guys be able to do it? This is what she said. This is how their teacher says. Their teacher says, do this. That times that is always equal to that times that. And then you can work out what this unknown amount, let's call it X, is. Should we try and see if her method works? Because so far I found her method's great. So if they give you 5 grams of that instead of 6, then that should be just less than 28. So let's just try her method and see if it works. I think you can see that. Okay. So let's say 5 times 28 equals 6x. Therefore, x equals 5 times 28. Let's do that. 140. And to get rid of the 6, I divide both sides by 6. The 6's cancel out. 140 divided by 6 equals 2.3. Sorry, 23.33 equals 23.33. You see what we did, guys? See what we did? Okay. Hoping that you got that. If not, watch the video and then just practice it. Now, what if they said to you, this is how they would phrase it. We've got 5 grams of that, and we've only got 20 grams of this nitrogen. Which of those is going to be the limiting factor? Okay, so we're going to react 5 grams of that with 20 of those. Which of those reactants is going to run out first? Now, you see what we worked out here is that if we've got 5 grams of that, we ideally need 23 grams, but we've only got 20 grams of this. So tell me, which is the limiting reagent? Is it this or is it this? Is it this or is it this? Okay, who says it's the 20 is the limiting reagent? Put up a hand. You're a bunch of geniuses. You really had your porridge this morning. Well done. Okay, so do you see what we did? They're going to give us 2 amounts. We're going to first work out the molar masses of them. We can take any amount. We could have done it the opposite way. We could have taken the 20 and worked it out that way, and we would have seen that this one is going to be the one that's in short supply. Should we do it the opposite way? Let's do it the opposite way. Let's get some practice. Okay, so let's just say, so now we know the 28. So let's suppose they give us 5 of that and 20 of that, and they ask, which one is in short supply? So now what I'm going to do is I'm going to do it the opposite way. I'm going to take this girl's method. I'm going to not do it with a 5. I'm going to say cross multiply. 28 times x is going to be equal to 20 times 6. So what is the amount of x that I'm going to need? Of this amount if I've got 20 grams of that amount. Okay, so I say 28x is going to be equal to 6 times 20. 6 times 20. And I'm trying to solve for x. Okay, so I divide both sides by x, cancels out. Well, that's stupid. I'm being real stupid here. I divide both sides by 28. And I'm left with x. Okay, the 28's cancel out. And my answer should be 6 times 20 upon 28. Okay, let's try that. 6 times 20 divided by 28. And I get 4.28. So 4.28 would be needed here. So then they're going to ask again the same question. Which is the limiting reagent? Which one are we going to run out of first? And the answer is that when we've used up all 20 of this, and they gave us 5, but they gave us 5 of those, we're going to run out of that one first, because we're going to use up, for that amount, we're going to use up 4.28, and we're going to left with about 0.7 of a gram of that at the end. So therefore, this one must be the limiting reagent. Okay, does that make, are you beginning to get some sort of idea of what's going on here? Some sort of idea? Okay, so I guess you guys know by now that I'm not big into notes. I'm just big into you understanding and remembering this stuff. So we're going to go to your textbook. Now, remember I said to you that in your textbook, I gave you a website which you must go to, and I'm going to just share this. Here you will see on that website, I've got all the pages of your textbook with lines down the side. So have some of you, just hands up, have some of you gone to this website and clicked on the pages and seen that there's lines down the side and you've highlighted your textbook similarly? Just hands up if anybody's done that. Anybody? Okay, but I did give it on Google Classroom. I gave you the link, and this would be page 193 of your textbook. Okay, page 193, and it's under limiting reagents. Okay, so what is a limiting reagent? It's when you're going to bake something in chemistry, which one have you got the least amount of? I just want to show you something. Okay, you remember the egg, the famous egg. This is how it started. This was my control, right? That's how it started out as. I've stuck inside there, but I've got a whole lot, I've got the whole eggshell. I think I dropped a little piece somewhere here. So this is my control. Now, what did my experiment look like after 2 weeks in vinegar? I don't know if you guys can see it, but I've just got a little bit of gooey gunk floating on top of, I don't want to put it on my laptop. Geez, no. But anyway, I've just got a tiny amount floating on top of the vinegar. So in this experiment, you know what is important? That you don't run out of vinegar. If your egg hasn't dissolved, you know why it hasn't dissolved? You had too little vinegar. So what must be the limiting reactant or reagent in your experiment, your practical? Must it be the eggshell or must it be the vinegar? Who says it must be the eggshell, must be the limiting reagent? Who says? Who says the vinegar must be the limiting reagent? Okay, you want to run out of eggshell first. So you must have a superabundance of vinegar and less eggshell. So what I did a few times was I just poured the vinegar out, careful not to lose anything, and then just added fresh vinegar, and then there's very little of the shell left at the top. And now what you guys have got to do is figure out what percentage of the shell was left. That's your practical. And you might ask, how are you going to do it? I don't know. Figure it out. You're scientists. The usual way would be to dry it on a piece of, would be to weigh it and dry it. Dry it and weigh it. Okay, but you don't have a scale, so I'll leave it to you to figure it out. Okay, so here we've got on page 193 of your textbook, we've got a very exciting reaction here. Okay, thermite. Now, what is thermite? It's like gunpowder, but it's a lot of fun. Don't ever do this at home, folks. But what you do is, okay, they define a limiting reagent is the substance that will be used up totally during the reaction. The amount of product is determined or limited by the reagent. Okay, so when the limiting reagent is used up, your reaction stops and you may be left with other reactants. Okay, so here's the thermite reaction. I'm really glad they included this because thermite is something I'd really like to try. In this reaction, you take 20 grams of aluminium mixed with 65 grams of iron oxide and ignite it. Determine which substance is the limiting reagent. Okay, so here's the balanced equation. Aluminium plus iron oxide goes to form aluminium 2 oxide and 2 ions. And you've got to, step one, balance the equation. Now they're going to give you that this is Fe2O3. You can't figure that out by yourself. And I'll tell you why. When iron rusts, this is just rust. There's 16 ways that iron can rust. It can form FeO. It can form Fe2O3. It can form different combinations of iron and oxygen. So they've got to give it to you, and they've got to give you that. And then you balance it. I think everyone here would be able to balance the equation. And then you got to calculate the relative formula mass, the same way as we did here, for each of these, right? And then you've got to do for the 20 grams of aluminium or the 65 grams of iron, you've got to do exactly what I did here. So when you've got your actual numbers, then you type the same kind of cross-multiply method. You're going to do it either for the 20 grams or for the 65. And then you're going to find out which one is the limiting reagent. And that's what they've done on this page here. You see what they did? They took the 20 of aluminium that you were given over the 54 grams, which is the molar mass. They multiplied it by that other reagent, which is exactly what they did. And then they got that we needed 59 grams of rust. 59 grams, but they gave us 65 grams. We only needed 59 grams, but they gave us 60 grams. So obviously the iron oxide is the one that's in excess. So our limiting reagent is going to be the aluminium. The aluminium, 20 grams of aluminium is going to be used up before the iron oxide is used up. And that is what is meant by a limiting reagent. Who thinks they've got some idea of this page now, how we work it out? Now, I looked at this, I thought, geez, why do they start with such a complicated thing? So that's why I started with this one, which is a simple one to work out a limiting reagent. So, you guys think you need a bit of practice? Guys need a bit of practice? Okay. Let's give you another reaction. Okay, I'm going to stop sharing here. And I'm going to go to this website. Just let me find it. Okay, here's a website. Let's share this with you. Here's another website for sharing, for balancing equations. Okay, I haven't really played with this one much. It says here, hydrogen plus oxygen goes to form water. Okay, could you guys, if you don't mind, write this down? 1 H2 plus 1 O2 goes to form, well, just write this down. Okay, now the next thing I want you to do is to balance it. Okay, so we always assume you got one of each. And when you think you've got this balanced, I want you to put up a hand. Anyone got a hand up yet? So when you think you've got it balanced, put up a hand. Okay, so here's the things you got to know. First of all, you got to know that hydrogen occurs diatomically. You've got to know that oxygen occurs diatomically. And we assume that by now you all know that hydrogen and oxygen combine as H2O. Everyone knows H2O. My grandmother probably knew H2O. Okay. So now we start. We've got 2 hydrogens. We got 2 hydrogens. Yes, our hydrogens are balanced. We got 2 oxygen atoms on the left. 1 times 2 is 2. We got 1 times, there's an invisible one there, only 1 oxygen atom on the right. So what do I suggest we do? Let's try increasing that to a 2. Yay, it says there that our oxygens are balanced, but it now says that our hydrogens are unbalanced. We've got 4 hydrogens. There's 1, 2, 3, 4 on the right. We've got 2 on the left. So what am I going to go and do? I'm going to raise that to a 2. You balance the equation. I'm a genius. Okay, fun playing with this. This is called simpop.org. It's also another site for balancing equations. Okay, now here's the next thing I want you to do. I want you to work out the molecular mass of 2H2, the mass of 1O2, and the mass of 2H2O. If I tell you that hydrogen has still got a molecular atomic mass of 1 and oxygen's got an atomic mass of, I think it's 16. 16. Okay, so work out grams of that, grams of that, grams of that for their formula masses. In the meantime, I'll just write that on the board. Okay, so we got hydrogen combines with oxygen to form HO. So what's the first thing I've got to know? I've got to know that's diatomic. That's diatomic, and the formula for that is H2O. That's the first things that I've got to know if I'm going to do stoichiometry. I've got to know hydrogen gas is diatomic, oxygen gas is diatomic, and the formula for water is H2O. Now look, 2 hydrogens, balanced. 2 oxygens, 1 oxygen, put a 2 there. Oxygens are now balanced. But look, 4 hydrogens, 2 hydrogens, put a 2 in front there. That's step 1. Step 2, let's find the formula mass for 2 hydrogen molecules. So we're going to go 2 times, you can put it in brackets, times 1 times 2, if you like, plus 2 times 16 goes to form 2 times 2 plus 16. So that's 2 times 1 is 2 times 2. That's 4 grams of that will react with 2 6s are 12, 32 of those. goes to form 32 plus 4, 36 grams of that. So who can't do that? Hands up, who can't do that? Okay, that's simple, right? Now let's suppose I give you, let's just think of a random number, horrible number. I give you 17 grams of that and 100 grams of that. Can you work out which one of those is going to be the limiting factor in making water? We're going into a water making factory. There's a drought. I've got 17 grams of hydrogen gas and I've got 100 grams of oxygen gas, and we are going to pump out water. I've just made up those numbers. I don't know which one's the answer yet. Which one of those is going to run out first? Which one of those is the limiting reagent? Okay, so now you know how we do it. Work it out. I'm going to go and make a cup of tea. Hey, that's the one thing you can do from home. Okay, just hands up who doesn't know what to do. Yeah. 1, 2, 3, 4. Okay. So let me help you. What you're going to do is this. Choose one. Okay, I'm going to ignore this one. That's what I'm given. And I'm going to make this amount X. Okay? Now I'm going to do the cross multiply thing. 4x equals 32 times 17. And I'm going to work out what x should be. So I'm going to say 4 times x is equal to 32 times 17. You know what I like about a method? I don't have to think about it. Well, it's a teacher's method. Now I want to find x. So I divide both sides by 4. That cancels out. And x is going to be equal to 32 times 17 divided by 4. 1. What do you guys get? 136. 136? Okay. Now, here's where you've actually got to have a few brain cells in operation. This is the only part that requires you to think. It says you need 136, but you've got only 100. It says you need 136, but you've got 100. So which one's the limiting reagent? It's going to be this one, which is your oxygen. Because if I've got 17 grams of that, I would need 136 grams of that. But I've only got 100 grams. So oxygen is my limiting reagent. Okay. Now, you geniuses, this is what I want you to find out. If oxygen is my limiting reagent, how much water in grams could I produce? Because I know the oxygen is the one that's going to run out first. I don't have to worry, I've got plenty of hydrogen. I want to find out how much water I'm going to produce. Is it okay if I rub this out? Have you got it down? Or maybe I can just do it next to it. Okay, let me do it next to it here. Let's do the same thing as we did there with our 100 grams of oxygen. So this, I'm going to rewrite this. 4 plus 32 goes to form 36. I just want to see if this girl's method works. If it doesn't work, I'm going to blame her. So now I'm going to say, but we, instead of 32, we use 100 grams of, we use our limiting reagent, because that's the one that's going to limit how much water is formed. So let's work out how much water will actually be formed there. So again, I say, I want to find out the X. So I do the cross multiply thing. I just want to see if it works. I'm sure it works. Okay, can you work out what X amount of water would be formed if we use 100 grams of oxygen?
So we must leave now, sir.
You can listen at the same time.
He's making us high.
He's also eating.
He's on the tea break.
Yeah, my limiting reactant is tea. I was running low on tea. Okay, so let's do the maths. 32 times X equals 100 times 36. Dividing both sides by 32 will leave X. That cancels out. And I'm left with 100 times 36 divided by 32 equals 112.5 grams of water.
Mr. Thomas?
Yes?
The lesson is about to end now. The bell is going to go. Just
Okay.
heads up.
Super. Did you guys get 112.5? And did you guys know why we use the limiting reagent to do this calculation? Because that's the one that's going to run out first. Hey, I don't mind. Just eat and enjoy your salmis there. I'll enjoy my tea. But I hope that you got how we use this cross-multiplying method to find our limiting reagent and to find our product. Lovely. So I can produce 112 grams of water. By the way, I'm only doing important stuff in grade 11. This you carry with you to matric. And that's why I explained last time we leave out the gas laws and we leave out the light stuff. But we will do it again. I don't want to deprive you of an education, but let's do the important stuff first. Okay, I'm going to stop recording now.